Okay, so this trial paper, I tried to work out from the bottom. From the bottom, I think that's the latest papers. Bottom, August 19. Okay. The more you do, the more you prepare. Okay. Effort, patience. Okay. At least for 10 sets before your trial. Before one paper two. It's a lot, but so do more than you more prepare. So what our plan for Monday is I just open up this from the bottom one by one. I just ask you any questions you have a problem. It means you already done, you already checked the mark scheme. The left, you don't understand. Okay, that's our style. Okay, today we will go through the topic, circular motion. Don't think this is not related for air. Sometimes this circular sometimes slip into the air, passing a little. So I think better to know these two. It's this guy is like sometimes comes in air, indirectly, average maybe 2 or 3 marks question. Okay, so okay. So okay, so motion in a circle. This is about moving in a circle. Okay, I want to ask you one question before we start with this. Your AS knowledge. Anything move with a constant speed? Can it accelerate? It's very important term. Anything move with a constant speed? Can it accelerate? Yes. Cannot. Can. They can accelerate. Okay. Constant speed, but can accelerate. How they can accelerate? Change direction. Change direction, acceleration is there. Okay. You should remember the hold on. Okay, so you still remember that day in AS, the first topic, vector changes in the vector subtraction. You still remember? Okay, just let's say a particle move, an object move with 16 meter per second to the right, and then immediately make a turning bottom 16 meter per second. Sorry. So what is the change? So it's moving to the right and then moving downwards. Something wrong with the sensor. Okay. So what is the change in velocity? So final minus the initial, right? Sorry about the line, I don't know. Okay. So final go down 16 and initial is negative of the initial, right? Negative of the initial, the arrow will be to the right or left. 16 is the initial, but it's negative of the initial, negative, because got negative. So the arrow going to be to the left. So this is your, we call it as what? Changes in velocity. Changes in velocity, right? Changes in, if speed constant means velocity can change. Can change what? How it can change? Direction change. Okay. So two ways you can change velocity. Either you change the magnitude or change the direction. You change direction, velocity change. When velocity change, do it accelerates? Accelerates what? What is acceleration? Rate of changes of velocity. If velocity change, it accelerates. Okay. So anything turn direction without changing the speed, still 16, but direction is changing. Do you need to apply force? You want to change something moving like this, you want to turn it like this way. Do you need to apply force? So you apply force, you need to apply force to make a turning. Okay. So when you make a turning, you need to apply a force this way. Then only you make a turning, right? So because if you apply force, there will be an acceleration. F equals to ma1. Okay, F equals to ma. So anything move with a constant speed do accelerates. Okay. So why I'm telling you this? Circular motion, circle, moving in a circle. Anything move in a circle with a constant speed, let's say 16 meters per second, constantly moving in a circle. Do it accelerate? Constant speed 16. So it's always accelerate. Okay. So anything move in a circular path, remember, although it move with a constant speed, it do accelerating. One year in AS, they ask this question. Moving in a circular path, they ask move with a constant speed, then they ask, is it accelerating? Answer is yes. Why? 3 marks question, if I'm not mistaken. Why? It accelerating. Why? Because direction is changing. Therefore, there is a changes in velocity. Okay, therefore, it's accelerating. Okay, so that's the point you have to highlight here. Okay, so this is the learning outcome. So we skip this, straight go to the point. So circular motion. Okay, anything move in a circular path, we have some sort of displacement called angular displacement. Okay, angular displacement. What is meant by angular displacement? How much of angle it covers at the center. That's called angular displacement. Okay. The unit radian. Okay. If you go one round, what is the angular displacement? 2 pi radian. 2 pi radian. So this is displacement. So it's a vector quantity. Anticlockwise, positive, clockwise, negative. Angular displacement. Okay, so the angle is angular displacement, but we put it in radian. Okay. Okay, we go. So it's a vector quantity. Okay. So next, we call something called angular velocity. Last time we have linear velocity. What is the linear velocity unit? Meter per second. Now we have angular velocity. What is angular velocity? The amount of angular displacement per unit time. How much of angle you covered per second? That's angular velocity. The symbol is omega. Omega, your Greek sign, omega. Not W, it's omega. So what is the unit for angular velocity? Theta over time, right? Theta over time, so the unit will be radian per second. Okay, so omega is in a differentiation form d theta over dt. Or your A level, you write changes in theta over changes in t, still accepted. But if you go one round, what is the time taken? Period, right? What is the theta? One round? 2 pi. So omega is 2 pi over t. More famous formula. Famous for omega is 2 pi over t. You know the period, you can find omega. Okay. So definition is theta over t, but 2 pi over t is more famous. And in terms of frequency, what you can write? 1 over t is frequency, right? So 2 pi f also omega. So 2 pi over t, 2 pi f, theta over t, omega. So if you know period, you can find angular velocity. Okay, many of you wear watch. Okay, so you have 3 needles there, 3 or 2 maybe, 2, 3. You have second and 2. Second and, minute and, hour and. Which has the greatest omega? Second and, minute and, hour and. Which has the greatest omega? Second and has the greatest angular velocity. Why? It has the shortest period. What is omega? 2 pi over t. Can you get me? How much is the omega of second n? How many radian per second? Second n. Second n now turning. What is the omega? Angular velocity of that second n. So 2 pi over t. Period how much for second n? Second n go for 1 round. What is the time it took? 1 minute, right? 60 seconds. 60 seconds. 0.1. So minute n omega is 2 pi over 60. Okay. So omega of minute n, minute n will be 2 pi over 60. So you get what? 0.1. 0.04 radian per second. This is omega. Okay. What is the omega of hour n? 2 pi over. What is the period of hour n? Hour n is 12 hours, right? Hour n to go 1 round. So change to second. 12 hours times 12 hours times 60 minutes times 60 seconds. Have to change to second a lot. Okay, there is angular velocity. What is the angular velocity of the Earth rotation? Everything is rotating. So all got angular velocity. What is the angular of the Earth rotation? 22 pi over 24 hours. So you know period, you can find angular velocity. Okay. So what is angular velocity means? The rate of angular displacement to the rate of angular displacement, the rate of changes of angular displacement. Is your angular velocity. Radian per second. SI unit, radian. Radian. And not even once I come across degree or radian. Okay, so now I believe you come across this formula in your admits. Sounds S equals to R theta. Let me play this. Okay, so S equals to R theta. You have learned this in your circular motion, right? Okay, now this S equals to R theta, you divide with time, both sides. So S over T is your linear velocity, meter per second. Your R is R, your theta over time is your omega. This is the second important formula. V equals to R omega. So you see this diagram? This circle, when it moves around, it has its own omega, and it has a radius R. What speed is traveling forward? What is the speed of the object at that moment? How fast is traveling? R times omega. You know radius times omega, you can find the linear speed. Linear speed is very, very famous for you. You learn, I think primary itself you learn about linear speed, but meter per second, how fast you are moving. How many meter you travel in a second? So V equals to R omega. Okay. So the formulas come from S equals to R theta. Now we are on the surface of the earth. We stick to the surface of the earth. We are going around. The earth is spinning. We have some velocity. We are not stationary. We are stationary on the earth, but actually we are turning, right? So you have some speed moving forward, right? So let's we found how fast we are moving forward. Can you work out how fast you are moving forward with using this formula? What information you need to find it? V equals to R omega. Come on, for fun. Try. What is the speed? You need the radius of the earth. Okay, check from the Google. What is the radius of the earth? 6,400 kilometers. How much? 6,000? 6,378. Okay, kilometer. Okay, this is your radius. Okay. Okay, get me the speed you are traveling now. Radius, V equals to R omega. So radius put in meter. 6378 times 10 power of 3. Omega is omega 2 pi ot. You know the period, right? Okay. Okay, period is what? 2 pi over t. What is the period of the Earth? 24 hours, one rotation. So 24 times 60 times 60. So what do you got? 464. So let me write the answer here. How much you got? 464. 464 meter per second. Change to 464. Okay. In kilometer per hour, how much? 464 meter per second. How many kilometer per hour? Times 3.6. 464 times 3.6. How much you got? Times 3.6. Change to kilometer per hour. 1,670. Okay, so what is your speed of car? What is the? I think 1,670 is how many times Formula 1 car speed? I think 5 times at least. You are traveling in the 5 times more faster than the Formula 1 car now. The surface of the Earth rotation. Okay, Earth rotation. But we don't feel it because since born you are on this planet. You used to. Okay. So yeah, so this is how fast the Earth is going around. Okay. So if you know radius, you know period, you can work out the linear speed. What speed you want to have. Okay. Okay. So if you know radius of the sun, let's say I'm asking what speed the Earth is moving forward. The Earth itself moving forward. What information you need to know? Radius between this from the center of the sun to the Earth, then the period of the Earth going around the sun. Period is 1 year. Then you can work out the speed. It's much more faster. Okay, so anyway, this is how linear speed related to angular velocity. Okay. Any question from this slide? This is the second important formula. Okay. Simple pendulum of length, for example, swings through an arc of 10 centimeter. Find the angle in theta. So what's the formula to be used? S equals to R theta, we get answer. This is like this is your first level of your advanced question. Okay, I think it's easy. Yeah? So the formula is S equals to R theta. You can get the angle. Okay. 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 You got the answer, eh? What's the answer? 3.25. 0.25, eh? 0.25 radian. Radian, eh? Got in radian, is it? Yes. Change to degrees, radian degrees times. How much? 180 divided by pi. Okay. Okay, class, another one. You have a circle. Let's say you have a minute and a huge clock. Let's say a huge clock embedded on the ground. The needle itself, let's say, is 2 meter length. Let's say 2 persons standing on the needle. Okay, huge clock, very strong one. Okay, the A and B. The clock, the minute hand is going around. The A and B, do they have same omega? They're standing on the minute hand. Minute hand is going around. So A and B got same omega? Same angular velocity? Do they cover the same angle at the center at any moment? Both of them have the same period, right? So both of them have same omega. Do both of them have same velocity? No. Which has the greater velocity? So B has a greater velocity. B has a greater velocity. So try to understand that. So omega could be same, but velocity could be greater, depend to the radius. More further, more greater the speed. Okay, this slide, just now I brief you. Okay, omega 2 pi over t and 2 pi f. This is a very common one. Okay. Okay. Recall one revolution goes through angular displacement is 2 pi. Time taken is a period. Frequency is the number of revolution for 1 second. 1 hertz per second. The word revolution is not a unit. Sometimes they tell you like 5 RPM. Let's say 200 RPM. Out of RPM. Revolution per minute. RPM is actually another unit. It's like another indirect unit for omega. RPM. But cannot be used for calculation. RPM must convert to radian per second. How do you convert RPM to radian per second? RPM change to rad per second. What do you do? 200 revolution. 1 revolution, how many radian? 2 pi. So 200 revolution, you want to change to radian, you times with 2 pi. Sorry. 2 pi. Okay. 2 pi. Over minute, you want to change to second? Minute, you want to change to second per minute. Per minute, you want to change to per second. So divide by 60. So RPM changed to radian per second, you times with 2 pi over 60. Okay. So radian per second is SI unit. Easily can be used in the formulas. Okay. Radian per second. Okay. Okay. This main hand has a large clock of 3 meter long. What is this mean angular speed? So I think we done this. Okay. 2 pi over t. 2 pi over t. T is what? Minute end. Minute end. What is the period? 60 minutes. So 60 times 60 a period. The mean end of a large clock 3 meter long. What is its mean angular speed? So angular speed is omega equals to 2 pi over t. So 2 pi t is how much? 60 times 60 minutes at minute end. Then you get the answer. Radian per second. Okay. The 3 meter is just trick you, extra information. Doesn't use in the calculation. Okay. Okay. Okay, your turn. Come on. You try. Give me the so far. You learn about omega 2 pi over t, v equals to r omega. Means for you. Omega is theta over t, 2 pi over t, 2 pi f, v equals to r omega. Okay, so you got the answers. So what is the first answer? Rotation of, or the frequency of rotation. Frequency of 6 point or 6.7. 6.7 times 18. 15. 15 hertz. Of course, the period, you know, right? 1 hour period. Then angular velocity is omega is, yeah, you can go for 2 pi over t. Yeah, 2 pi over period. Period, you can put here the period, and you get the answer. Okay, how much angular velocity you got? 19. 16 radian per second. The linear speed equals to r omega. So r is, you know, then use your angular speed. So what do you get?
2 meter per second.
2 times 10 power 6, 6, right? Meter per second. 2 times 10 power 6 meter per second. Write it in 3 SF. Okay, straightforward warm up first. Okay, now you come to a little deeper into the circular motion. So we know that anything move in a circular path, do it accelerates? Yes, it definitely accelerates. Why? Because direction is constantly changing. Therefore, there is a change in velocity. Therefore, it accelerates. Accelerates the rate of changes of velocity. But now, which direction it accelerates? They found the acceleration is towards the center of the circle. We found the acceleration is towards the center of the circle. You see, this is your, let's say, V1. This is your V2. Okay. What is the changes in velocity vector diagram? Changes in velocity. What is changes in velocity? V2 minus V1, right? So we follow this diagram. V1 was actually vertically up, then V2 slightly diagonal to the northwest direction. So you want to find what are the changes in velocity vector diagram. So draw the V2 first. V2 is where? V2 is this way, right? Sorry about V2 is this way. Sorry. So let me draw the diagram. V2 here. Then where's your V1? Negative of V1, right? V2 minus V1. Right? So minus V1. V1 is up. Negative V1 must be down, right? Down, down. So changes will be like this. This is the changes in velocity. The changes in velocity is found to be directed towards the center of the circle. If do it properly. You see, the V2 is here this way. Then V1 is down. The changes will be towards the center of the circle. Okay. But three quantities always same direction. Force, acceleration, changes in velocity, and changes in momentum. 4 things. This 4 quantity always same direction. Okay. If your changes in velocity is to the left, your acceleration is to the left, your net force is to the left. Your changes in momentum also to the left. Okay. We are quite familiar with force and A. Force and acceleration, of course, same direction. Plus, now please include the other two guys who are always same direction. Changes in velocity and changes in momentum. Okay. So, anything move in a circular path, it accelerates. Where it accelerates? Towards the center of the circular path. Earth going around the sun. Earth, do it accelerate? Yes. Where? Towards the center of the sun, towards the sun, it accelerates. Okay. What is the name of that acceleration? Special name given, called centripetal acceleration. Anything move in a circular path as a centripetal acceleration. Acceleration towards the center called centripetal acceleration. Okay. Okay, please try to understand the first point. Even when an object moving around with the uniform speed, same speed, its velocity is not uniform. What is the reason? The direction of the velocity v instant is a tangent to the circle. The direction of the velocity changes. The keyword is the direction of the velocity change. That's the reason. Hence, the object uniform circular motion is accelerating. This is like the 3 marks, like a not uniform 1 mark. Direction is changing 1 mark. Therefore, it's accelerating 1 mark. For the question for what? Anything move with constant speed, do it accelerate? For that question, these are the explanations. Yes, it accelerates. Why? Direction is constantly changing. So therefore, velocity changing. Therefore, it accelerates. Okay. Where it accelerates? Now you know, towards the center of the circular path. Okay. Okay, so in AS, there is, as I said, 1 year they give a question like moving like a part of a circle. Part of a circle, you know, like a pendulum, you know, pendulum. That day you did an experiment. Pendulum, this pendulum is like wobbling in a circle, like moving like this, conical circle, like this. Okay, it's here. It's moved in a conical circle. Okay. With a constant speed. Yes, they ask, is it accelerating? So the 3 points just now I told you. But in your mind now, you should know where is it accelerating. Towards the center of the circular path. That's where it's accelerating. Okay. So you imagine, anything move in a circular path, the acceleration is towards the center. Not only a circular path, a slight curvature, which is an arc of a circle, also will lead to a centripetal acceleration. Arc of a circle, just making a turning, a small turning, but you never do a complete circle, you just make a small turning. But that small turning is an arc, if you coin it, it's like an arc of a circle, right? So you are accelerating toward the center, you have a centripetal acceleration. Like you drive your car, because there is a road, which a curvature road. When you make a turning by using a car, the tire, you are accelerating towards the center of that curvature. Maybe the curvature is not complete circle. The curvature, if the curvature are like this, you see, you are just moving from here to here, then you're moving straight line, let's say. You are still accelerating, although this is the curvature you did, but if you prolong it, it's a circle with a particular radius. You are accelerating at that moment when you make a curve. Centripetal acceleration do happen. Okay. Okay, so now in your syllabus, this is your centripetal acceleration formula, v squared over r. Okay, v squared over r omega squared. It's a half page of derivation. They use 2 circles. The first circle they use is the s theta. S and theta here, and the radius is r. S equals to r theta. And the other triangle they do is the velocity. The velocity just now. Just now this is v1. This is v2. V here. Then another v coming down here. If the move with a constant speed, move with a constant speed, both magnitude will be v and v. So this is your changes in v. Okay, this angle will be theta. Okay, so first triangle is this is R, this is your R, this is your S, this is your theta. Another triangle is like this. This is your V, changes of V, theta. The similarity between these two triangles actually is a curve at the actually the it's not a straight line. The S is not a straight line, it's a slight curve, but we take a very short distance until it like a straight line. A short period of the V1, you know, the V1 and V2, the time we take is very, very short until the curvature, right, is like about straight line. Okay. Okay, now theta for the first equation is what? Theta first equation is S over R. Second equation, theta is what? Theta is S equals to R theta, you can use. So S. So in this case, S is changes of V. Changes of V. Theta will be what? SR. So S will be changes of V and R will be V. Yeah. So changes of V over V will be same as S over R. It be like that. Okay, because theta same. Because they want to get acceleration. How to get acceleration? Acceleration is rate of changes of velocity, right? So what is missing in this both equation? The t. So mathematically they did what? They divide both sides with the time, changes of t. Changes of t. So what happened? Here we can changes of v over changes of t. The v, right, they bring up. So S v over r changes of t. Okay, put like this. Changes of v over t is actually what? Your acceleration. S over, v over t is what? Yeah. Sorry, no. S over t is what? S over t, sorry. S over t is your v, right? So become v squared over r. So you get this formula. A equals to v squared over r is the centripetal acceleration formula. The derivation not necessary, you need to know, but how to use this formula, it's important. Okay, A equals to v squared over r. Okay, so v squared r, you know how they got the second one? R omega squared. The v they substitute as v equals to r omega, so they got r omega squared. Yes, so this is your third formula for today. Acceleration, centripetal acceleration, v squared over r omega squared. Any questions so far? This is for today's lesson. Okay. Introduction of circular motion. Okay. Very useful for AS. If you see any question with making a circle, you must know it accelerates towards the center. Why? The reason you have to know, they can ask in AS. Okay. Because direction changing, velocity changing, therefore that is accelerates. Okay, any questions? Questions there? Yeah.
That means the acceleration is based on the acceleration towards the center.
Yeah.
The speed based on my
yeah, speed, no direction.
velocity.
Ah.
So that means that my acceleration is towards the center.
Yeah.
So my speed, what do you call it, vertical speed, that time, that acceleration is different.
Yeah, that's called tangential acceleration. This is radial acceleration.
Radial acceleration is towards the center.
Radial acceleration towards the center. Yeah.
But the acceleration of speed, yes, the speed.
The tangential acceleration is different, yeah. But we won't go to that tangential acceleration in syllabus. We always say constant speed. So therefore, no tangential acceleration. Only radial acceleration. We call it centripetal acceleration. Yeah, good to know the extra one, tangential. That's further studies. For now, just we focus to the radial. We just focus to constant speed. Okay. Okay, thanks.